Hi students, welcome to the video class of Machine Learning Laboratory. In this video, we'll be seeing our first lab program, that is implementation of Finder's algorithm. Finder stands for finding the maximally specific hypothesis. Right, finding the maximally specific hypothesis. To understand this Finder's algorithm, we should know few terms like concept learning, general hypothesis and specific hypothesis. What is concept learning? The task in concept learning is the learner should learn to categorize. The learner should learn to categorize the given object. Right? If we take most of the human learning is based upon past instances or experience. For example, how do we categorize the vehicles? With some features like make, model, we are able to categorize the vehicles into cars, trucks, buses, motorcycles and so on. These features are known as concepts in machine learning. Similar to this, machine can learn from these concepts to identify whether the object belongs to this category or not. Right? Machine can learn from these concepts to identify the object whether it belongs to the given category or not. And coming to the definition, concept learning can be termed as a problem of searching through a predefined space of potential hypotheses for a hypothesis that best fit the training examples. HOPOTHESES is plural and HOPOTHESIS is singular. Right? And the meaning of hypothesis is explanation for something. I have a set of explanations. From this, I select the best one that fits the training examples. And general hypothesis is, as I said, hypothesis is explanation for something. For example, if I want to write a general hypothesis for ordering a burger, I'll write, I want a burger. It is general. It can be anything. I didn't specify what type of burger I want. So it can be of anything. Right. So general hypothesis, the notation is question mark. And for specific hypothesis, the notation is null. Right. So for the same thing, if I want to write a specific hypothesis, I can specify what type of burger I need. Right. You can write like I want a cheeseburger. Right, that becomes a specific hypothesis. Coming to this algorithm, this Finder's algorithm, I'll be considering only the positive examples. I'll discard all the negative examples. Right, and in every iteration, I'll check each attribute value in the instance with the attribute value in the hypothesis. If both are same, I'll just proceed. I'll not do anything. I'll just proceed to the next attribute. If it is different, right, I have to put a question mark in the hypothesis. Right, in the hypothesis attribute place, I have to put a question mark. And the limitations of Finder's algorithm is, if the hypothesis is consistent throughout the data, I cannot find the specific hypothesis. Because in a Finder's algorithm, it will not consider the negative examples. It works only on the positive examples. So I could not find the most specific hypothesis. And one more limitation is Finder's algorithm does not provide a backtracking technique. Coming to the implementation part, I have taken a smaller data set to decide if a person wants to go for a walk or not. Right? To decide if a person wants to go for a walk, I have taken a smaller data set and the concept, right? What is concept? The feature of this particular problem will be, on what days does a person likes to go on a walk? On what days does a person likes to go on a walk? Right? So I have 4 instances, right? I have 4 features on which the person decides to go for a walk or not. Right? The last attribute will be your decision attribute or class attribute. The last one will be your decision attribute or class attribute, and we'll be considering the first 6 attributes, right? So initially, H naught will be our general hypothesis, right? And if you check out of this 4 instance, right, out of this 4 instance, only 3 are positive examples and 1 is negative. I'll be considering only the positive. I'll be discarding the negative, right? So initially my hypothesis will be my general hypothesis, right? I have taken my first positive example. I have written as it is: morning, sunny, right, warm, yes, mild and strong. Next, what I have to do, right, take the next instance. Since it is -1, I'll discard it, right? Coming to the next instance, it is a positive one. So in this instance, take the first attribute and compare with the first attribute of your hypothesis. Take the first attribute of your instance and compare with the first attribute of your hypothesis. Morning, morning, same. So it will be morning. Next attribute in your instance is sunny. Hypothesis also it is sunny. Compare both sunny, sunny. So it should be sunny. Next, here it is moderate. Here it is warm. Moderate or warm, but both are positive examples. So I'll put a question mark. It can be of anything. General hypothesis, right? Next attribute is yes. In hypothesis also it is yes. So here it is yes. Next, normal, mild. Both are different. So put a question mark. Right? Next, here it is normal. Here it is strong. Both are different. Put a question mark in your hypothesis. Right? Now this is your hypothesis. Check the next instance with this hypothesis. Right? Again, it is positive example. So I'll be considering this. The attribute, first attribute of this instance is evening. In hypothesis, it is morning, evening, morning, both are different. So in hypothesis, I put a question mark. Sunny, sunny, right? Both are same. Sunny, sunny, both are same. So I have written sunny. Next, here it is cold. Here it is question mark. Cold or question mark. So it is question mark, right? Here it is yes, yes. In instance it is yes, in hypothesis also it is yes. So here it will be yes, right? Here it is high and question mark. So in hypothesis it will be question mark, right? Strong and question mark. So it is question mark, right? So this is your final, right, specific hypothesis. Question mark, sunny, question mark, yes, question mark, right? So this is the maximum specific hypothesis for the given data set. Students, I'll show the Python code for Finders algorithm implementation. You can download your Anaconda Navigator and you can use your Jupyter notebook for machine learning programs. And for the first program, it's enough to import a CSV package alone. And here I'm creating an empty list and you can open your dataset file. Dataset, it should be as a .csv file, and I'll show this. This is my data set. I have 4 instances and it should be a .csv file, and this CSV file, it should be in your file structure. I'll show it. Oh yeah, here it is, data.csv. It should be in your file structure, right? So you can open this data.csv file, and CS file is your file handler, and this CSV has a built-in function known as reader, and the attribute for this reader function is your file handle, right? You can open this file and take all the instances and append to your list. That's what I'm doing here. A.append row. Take every instance row by row and append to your list. And if you want to check, you can print and check it. This is optional, right? So I have printed. I got all my 4 instances which is in my data set. And after this, I have to count the number of attributes. As you know, if you take an instance, it has 7 attributes and the last one is your decision attribute, or I can say as class attribute, right? So excluding the last attribute, the remaining 6 I have to count it. So what am I doing is like length of, take the first instance, right? Subtract the last attribute, right? So length of a of 0 minus 1. So excluding your last attribute, you'll get the count of your remaining attributes and it will be 1, 2, 3, 4, 5, 6. So the number of attributes will be 6 here, right? And the next step is, what am I doing is like I have to specify my generic hypothesis and specific hypothesis. For generic hypothesis, as you know, the notation is question mark, right? Since I have 6 attributes, 6 times I need this question mark. So what am I doing is like question mark into number of attributes. That many times I am repeating this question mark. Similarly, for specific attributes, you know the notation is null. So here in this program, I am not using null. Instead of null, I am using 0. So similarly, this 0, how many times I want to repeat? This number of attributes time I want to repeat. That's what I am doing in these 2 lines. So you can print and check both your generic and specific hypothesis, right? So here it is, 6 times you got your question mark and 6 times you got your 0. Right, so this depends upon the number of attributes in your data set. And this part is your algorithm part. So for the very first time, what I'll be doing is like, take the first instance, right? As I told, your data set, you can check here. How many instances are there? 4 instances are there, right? So 4 instances, and in each instance, the last attribute will be your decision attribute, or I can say as class attribute, right? Excluding this last attribute, remaining attributes of your first instance, for the very first time I'm putting it in hypothesis, right? So hypothesis is equal to first instance, right? So what is this part? I don't want this last attributes. Excluding this last attribute, the remaining attributes I am storing it in hypothesis, right? Next, what am I doing? This is a for loop for I in range of length of a. As you know, my data set has only 4 instances, right? So how many times this for loop will iterate? For 4 times. Length of a. What is a? The list, right? Where we have appended all our instances, right? So this for loop will iterate for 4 times since I have only 4 instances in my data set, right? So inside this for loop, right? This is a of I. For the first instance, number of a of I of number of attributes. Check the last attribute whether it is equal to yes. Because you know in finders algorithm, it considers only the positive examples. It discards your negative example. So I have to check my last attribute whether it is yes or no. Take the instance, right? So for the very first time, I'll be taking my first instance, go to the last attribute, check if it is yes. Only then it will come to the next step. So for j in range of number of attributes. So this j loop is for the number of attributes. So number of attributes, you know, I have 6 attributes. So this j will iterate for 6 times, right? So here if a of ij, right? So first instance, first attribute, if it is equal to hypothesis first attribute, right? If it is equal to, as per the algorithm, I will not do anything. I will move to the next attribute. If it is not same, right, I have to replace hypothesis attribute with question mark. That's what I am doing here, right? So if it is not equal, hypothesis attribute will be question mark. If it is same, it will not do anything. It will move on. It will check the next attribute, right? So here, every time I'll print the hypothesis, and the last, in every iteration I'll be printing my hypothesis, and the last hypothesis will be the final one, that is maximally specific hypothesis, right? So here you can give run and you can execute it. This is my output. So here you can see the first instance of my data set is sunny, warm, normal, strong, warm, same. Sunny, warm, normal, strong, warm, same. Sunny, warm, normal, strong, warm, same. As I said here, right, first instance will be the hypothesis in the first iteration, right? Hypothesis 1 will be your first instance, right? Now this is my hypothesis. Coming to the second instance, I compare this second instance in the hypothesis 1, right? So before comparing, I have to check whether it is a positive example or not. It is a positive example. So what I can do, come check the first attribute of your instance and the first attribute of your hypothesis. Both are same, sunny, sunny. So what will be the hypothesis? It is sunny. Next attribute, warm, warm. Both are same, so here it is warm. Next attribute is normal. Here it is high. Normal, high, different. So I got a question mark. Next it is strong, strong. Strong, strong. So it will be strong. Next warm, warm. Both are same. I got warm. Next it is same, same, same here. Right. Now this is my hypothesis. Now check this hypothesis with my third instance, right? And you can see third instance is a negative example. So if it is a negative example, finders will not consider negative example. So the next hypothesis will be the same as that of the previous one. Sunny, warm, question mark, strong, warm, same. Right. Now this is my hypothesis. It has to be compared with the last instance, that is the fourth instance. Compare. First attribute is sunny. Here it is sunny. Right. So I got my hypothesis as sunny. Next it is warm, warm. Right. So it is warm. Next here I have a question mark and I have high here. So it should be question mark. It should be question mark. Next it is strong, strong. Both are same. So I got strong. Next warm, cool. Right. This one warm and here it is cool. Both are different. So I got a question mark here. And the last it is same and change. Both are different. So it will be a question mark here. So this is my last hypothesis, and this last hypothesis, right, I'll be printing, right, print hypothesis, and this will be my maximally specific hypothesis for training set, right, sunny, warm, question mark, strong, question mark and question mark, right. So this is the simplest machine learning algorithm. Hope you understood the implementation part. Thank you.